Welcome to Discovering OpenSees webinar. My name is Vesna Terzic, and the topic for this webinar is getting started with OpenSees. This webinar is designed for the new or beginning users of OpenSees, but can be also beneficial for intermediate users. In this seminar, I'm going to introduce you to OpenSees. I'll introduce some basic, introduce you to the basics of the Pickle programming language, as you have to know it in order to efficiently use OpenSees. Then I'm going to show you how to download OpenSees interpreter and install Pickle PK on your computer. Then I'll give you a tour through OpenSees resources. Like I'll show you how to use command manual, examples manual, message board, and at the end I'll wrap it up with showing you an example of how to create and run a small structure. Finally, at the end, I'll try to answer all of your questions. So OpenSees is a software framework that is written primarily in C++ for simulation applications in earthquake engineering using finite element methods. It is an open source software framework, which means that any user of OpenSees can create their own materials and elements and add them to the OpenSees framework. It is also a communication mechanism for exchanging and building upon research accomplishments. This means that the whole research community contributes and helps OpenSees grow as a community software framework. It's very fast, stable, and efficient in solving large nonlinear models with multiple runs. But to make a finite element model in OpenSees, you need to know basics of Pickle programming language. Someone may think that this is a disadvantage, and this may take you more time to learn OpenSees. I rather think of it as an advantage, as it gives you lots of flexibility with building your models and doing multiple runs on the same model just by one click, which I find very advantageous. The architecture of OpenSees is fairly simple. You have a model builder that adds all objects, modeling objects, to the domain. These are elements, nodes, constraints, load pattern. Domain keeps the state of the model at time t, and then analysis moves the model from state at time t to state at time t plus delta t. And then you have a recorder that monitors user-defined parameters of the model during the analysis. Unlike some commercial applications like SAP or other softwares, if you don't specify the recorders inside of your file, you won't have any output after you finish your analysis. So to see the results of your analysis, you really need to define all recorders or all recording objects for your model. So how do people use the OpenSees framework? Few of them provide their own main function in C++ and link to framework, but most of the users just use OpenSees interpreters. The most used one is OpenSees.exe. And what are these interpreters? There are extensions of Pickle interpreters which have been extended to commands for finite element analysis. for modeling, for analysis, for output specification. Being interpreters means that the files you create and submit to the OpenSees interpreters are not input files. You're actually creating and submitting small programs. So in order to be able to use OpenSees efficiently, you need to know basics of Tcl programming language. It is a dynamic programming language that is string-based. It supports variables and variable substitution. It evaluates expressions. It has basic control structures like if, while, for each. You can define procedures. Procedures are equivalent to functions if you're familiar with MATLAB. And then it has capability for file manipulations, like it can read, write files, and it can source other files as well. The syntax for any Tcl command is just command followed by the list of arguments. To learn basics of Tcl, I suggest you to look at the tutorial, whose link is shown here. I'm quickly just going to go there and show you what it is. It has like 49 topics that describe different functions or commands of Tcl. To really get familiar with it and build some basics to be able to use OpenSees. If you read first maybe 20, you'll learn like most of useful stuff that you need for OpenSees. However, I'm going to go through some examples just to explain you the basic functionality or basic commands of Tcl language. So I'll start with defining variables and with variable substitution. First, the command to assign a value to a variable is set, as shown on the screen. So here in this example, I'm assigning a number 1 to variable a. So the command is set, and the arguments for this command are variable name and the value that you want to assign to this variable. Next example shows what's going to happen if I assign string a to variable b. If you look at the b, you're going to see that what it contains is a. It's not 1. So in order to assign 1 that is in a to variable b, you need to have like $sign in front of variable a. So now in variable b you have value 1. To evaluate any expression, you need to use command expr followed by any mathematical expression that you want to evaluate. In this example, I'm just summing 2 and 3. Next, I want to show you the square bracket function. So if you have any command in the square bracket, inside of the square bracket, that command is going to be executed immediately. So for this case, for this example, I'm defining b and assigning the value that is calculated from the expression in the brackets, and it's 2 plus 1, and the result is going to be 3. So b now contains value 3. Another useful set of commands is for creating the list of vectors inside of Tcl. Your list can be created easily just by assigning to a value the list of values. In this case, I'm assigning 1, 2, and 3. To get the length of this vector, the command for it is length, and after the argument for this command is just the name of the list. Next command is lindex, that you can use to get any item or any element from the list. Here I'm asking for the first vector, for the first element in the vector A. I made this example just to show you that the numbering in Tcl starts from 0, not from 1. So in order to get the first element in the list, you need to specify 0. And one more command that may be useful for manipulating with lists is append, followed by the name of the list and item that you want to add to a list. And here I'm adding 4 to the list A. So now my list has 4 items, 1, 2, 3, and 4. Next, I'm going to show you how to write into a file. Here, I'm just opening the file with the name tmp. VW, I'm saying that I want to write into this file. Then with the puts command, I'm defining what I want to write in it. Syntax for puts command is that the first argument is the name of the file in which I want to write, and the next argument is like a string that you want to write into that file. After I finish writing whatever I wanted to that script, I have to close it by command close, followed by the name of the file. Another important command, a Tcl command, is source, which is useful for sourcing any file. This is very useful command for OpenSees, which allows you to write your finite element models into a file and to run them through OpenSees just by simply sourcing that file that contains your finite element model. Next, I want to show you different control structures. The first one I want to show you is for loop. The syntax for this command is for. Then you have initiation command, you have test, you have next or incrementation, and at the end you have your body. The way it works, first you set your variable to any value you want, which is in this case I'm assigning value 1 to I, and this command is executed only once at the beginning. After that, I'm doing my test, so I'm going to the test and checking if the value inside of variable I is smaller than 10. And if it's true, it goes to the body and does whatever it's asked to do. Here I'm intentionally showing you another aspect of using puts command for printing things to the screen. So the syntax for this is after you have your puts command, under the quotes you can write anything you want, and what is under the quotes is going to be printed to the screen or to your terminal. In this case, I'm printing I equals to 1 for the first step inside of the loop. After the command inside of the body is executed, it goes to incrementation step, where the variable I is incremented for any value. In this case, I'm incrementing it for 1. After that, the test is executed again, and if the test shows to be true, you go to the body and so on until your test is negative. Next command I want to show you is for each. The syntax for this command is for each followed by the variable name and the list through which this variable name iterates, followed by the body of this command. So what it does for each run, value has one of the items. The value is assigned one of the items from the list, and if you go to the body and see your value here, it will have that item from the list. And this small code actually is for summing all the elements from the list. In this case, the total, the summation of 1, 2, 3, and 4 is 10. Next, I want to show you the syntax for how to define procedures. In Pickle, the command for creating procedures is proc, followed by the name of that procedure, and followed by the all input values that are going to be used inside of the body of the procedure. Other important things that are worth of mentioning is how Pickle actually adds, subtracts, multiplies, and divides number depending on what you assign to it. So in case you want to add, subtract, multiply, or divide two integer numbers, the result is going to be an integer. So in case I want to evaluate 1 divided by 2, where 1 and 2 are integers, the result is going to be 0. In case one of them is integer and the other one is floating point number, the result is going to be floating point number. So in the next example, if I have 1 point divided by 2, where 1 point is floating point number and 2 is integer, you're going to get exact result. I also want to mention that Pickle does not work with ordinary decimal fractions, but with binary fractions, which leads to not completely exact results, something that users would expect. So an example would be if you divide 1.2 with 0.1, you would expect to get an answer. Exact answer would be 12, but what you're going to get is 11.9999. Next, I want to show you how to actually download OpenSees and Pickle to your computer. How to install Pickle on your computer, so you can really run any file of your finite element model. Here on this page, I have the links that will lead you directly there. Instead of using these links, I'm going to actually open Google browser and to show you how you can easily browse through OpenSees web page and find it yourself. So if you type OpenSees in the Google search, you'll see you'll find the link to the OpenSees page. The important things for the beginners are listed on the left side of this page. So what we need to do, what we want to do now, we want to download OpenSees Interpreter and Pickle. So in order to download it, first you have to register. If you never registered before, you have to register. You're going to do it by clicking on the registration link. Sorry, I have to log out from my account in order to demonstrate this because I was already inside. I'm going to go back to Okay, now if you click on registration, you're going to get to this page. You have to agree with the terms in order to proceed. And after that, you have to define your username, provide email address, and create a password, which will lead you to creation of your account on OpenSees. After you submit all this data, you have your login information that you will use later on to log in into the system. But since I'm a registered user, I can log in and download the latest version of OpenSees. The blue screen, there are two links. One is for OpenSees executable, and the other one is for Tickle. So if you click on OpenSees executable, you'll be able to save it anywhere on your screen, on your computer. So I'm just going to create a new folder where I'm going to place this version. I'm just going to call it OpenSees. So after you save it, you'll have to go back. You have to go back, open it, and extract it. So inside of this folder, there is OpenSees executable that you're actually going to use to run all your files. By double clicking of it, you're going to activate it. At the top of the screen, you'll see that now you're inside of OpenSees 2.3.1 version. And from this terminal, you can run all your OpenSees files. For now, I don't need it, so I'm just going to exit it. Next thing you have to do, you have to download and install it on your computer Tickle. So I'll save it in the same folder. So after you saved it, it takes some time until it's completely saved on the screen. Okay, now you have it. It's there. Actually, I have it on my computer. And next step would be installation of this. After you double click on it, you have to click run, and it will start installation on your computer. Since I already have Tickle installed on my computer, I cannot install it twice. But I'll show you where you can find the guide on how to install it, properly install it on your computer. So if you go to user documentation, you'll find many useful resources for the beginners. So inside of this, in getting started manual, there is like a link to how to download and install OpenSees. So at the bottom of the page, you'll see instructions on how to install Tickle on the computer. After you click on the run, you'll be asked to accept the license agreement. After you accept it, it will ask where do you want to save it on your computer. The important thing is like the default location is C disk. You just have to change it to C program files and to save it there. After that, you just have to click next until you finish installation. Next, I want to show you how to efficiently use resources that we have online, like getting started manual, command manual, examples manual, and message board. Here on this page, I have direct links to all of them. But again, instead of using this, I will just browse them through our online wiki page. But I'm keeping this here as I'm going to post later on. I'm going to post this document online for you to see it. But still, I feel it's better if I try to find it online. So all these useful documentations can be found by just clicking on your left side on this link to user documentation. So to really get to know the basics of OpenSees and to get started with OpenSees, I suggest to go to Getting Started manual, where on one fairly simple example, the process for defining a model, for creating a model and running different types of analysis. Here you have like gravity load, static pushover, cyclic lateral load, and dynamic ground motion. You're going to really get to know about the structure of OpenSees. I just want to show you that it's a very simple portal frame, which is reinforced concrete with elastic beam and column elements and some gravity load at the top. So next thing I want to show you is like command manual. By clicking on the command manual here, you're going to be able to browse and find arguments for any type of for any command for creating finite element models. So let's say when you start creating your model, first you create your model, and all the commands for creating the model are under modeling commands. I'll just click and show you one of them. For example, if you want to create any uniaxial material, let's say you want to create steel 01, you're going to find the syntax for the command that you have to follow in order to create that material. So here I'm creating uniaxial material steel 01. In order to do that, you have to define the material tag, which is integer tag identifying material. After that, you define like yields, strengths, initial elastic tangents, and strain hardening ratio. And all these arguments that you see on this line are described below. For some of the materials, you will also see the basic curve that it follows, and maybe some hysteretic behaviors. Inside of the analysis link, there are like all commands that you need to use in order to define analysis objects are inside. To create the output, you're going to find all commands under output commands, where you will find the syntax for recorders and similar things. And then other than this, there are also some miscellaneous commands which will help you see the results, the results that you find useful on the screen is at the time of running your model, or there are also some commands for removing or resetting your model. Removing, when I said removing, I meant like removing, let's say, load pattern or constraints or whatever you don't need at some point of analysis. And at the end, we have like database commands for creating a database for your system. And next thing I want to show you is how efficiently use examples manual. By clicking on examples, you're going to get to the page where you're going to see three very important pages, links actually. One is the examples manual, inside of which are some like really basic and simple models. I'm just going to click on one of them. and show you that you have the full description of the model. And then below that, we'll have instructions on how to run example, then how to create the model, with descriptions of all basic commands that are used, then how to define recorders for that specific example, how to apply the load, gravity load analysis, and here I have also dynamic ground analysis. And this is all explained step by step. So this is really, after you go through the getting started manual, I suggest you to look at these basic examples first. And then once you become more familiar and you develop like some knowledge of OpenSees, then I suggest you to look at the advanced example manual. It covers very broad range of problems, different materials, from simple elastic to nonlinear materials and elements, the 3D structures. And the only disadvantage of this example manual is, like, if you go to any of them, let's start with the first one. I'm sorry. Here's example. You won't see much descriptions. Like, if you go inside of this one, you're just going to find the files that you have to download in order to run these examples. There is no explanation how each line inside of this code was created, and it only gives you a suggestion. No, it gives you it only tells you how to run these files in order to run this model. And at the end, I want to show you that there is also like part of this page that is for practical examples, and these examples are posted by OpenSees community. That can be any of you, and this is meant for sharing whatever you think may be useful for the OpenSees community. And we really encourage like sharing of files and helping other people learn OpenSees really quickly. So after this, I want to guide you through an example just to show you how easy it is to create a model in OpenSees. For this, I'm going to go to this basic manual, to one of these examples. It is basically doing Eigen Analysis of the two-story 1B frame. This example is taken from, it's actually example 10.5 from Dynamics of Structures book by Professor Chopra. The first story elements of this frame all have the same properties, and the second story elements also have the same properties, EI. The mass of the first floor is 2m, and the mass of the second floor is m. So I'll go now step by step and show you how I actually build the model and how you perform Eigen Analysis. So first comment, it's always the first one, is the one that creates the model, and it defines the spatial dimension of the problem and degrees of freedom per node for each node. In this case, it's two-dimensional portal frame, so it has the dimension of 2, and this model has 3 degrees of freedom per node, that there are 2 translations and 1 rotation. To utilize what we learned about Tcl programming language, I'm going to define this model using variables. So I'm going to assign some values in order to define mass, cross-sectional area, moment of inertia, modulus of elasticity, bay length, and story height. And I'm just going to use their names throughout the example, as I find it easy for debugging in case something goes wrong. For me, it's easier to have to work with variables than with like writing the numbers inside of all these commands. So after we build the model, first thing we have to do is to create the nodes or to define the nodes. If you go to syntax for the node command, you'll see that it asks you to define the node tag followed by the nodal coordinates. And there is optional commands for defining also mass that you assign to that node. So since my system is two-dimensional, I need to define only two coordinates, x and y, in order to build my nodes. Next, I have to define boundary conditions. In order to define boundary conditions, you need to use command fix. Again, I'm going to go into fix command to show you the syntax. You need the node to specify the node tag and constraint. If the node is free in any direction of freedom, it's 0. If it's fixed, then you have to specify 1. So in my case, I'll go back to my sketch. For this example, nodes 1 and 2 are fully fixed, which means that I have to constrain all 3 degrees of freedom at each node, 1 and 2. So my command is going to be fix. Node tag is 1, and I'm fixing all 3 degrees of freedom. And then same for node 2. As I'm doing Eigen Analysis on this model, I need to assign masses to nodes. And here I had mass of 2m at story 1 or at floor 1 and mass m at floor 2. I'm going to assign half of the story mass to each node. So nodes 3 and 4 are going to have mass of m, and nodes 5 and 6 are going to have mass of m over 2. So that's what I'm showing here. At node 3, I'm assigning only the horizontal degree of freedom. I'm assigning mass at nodes 3, 4, 5, and 6. Next thing you have to do is to define geometric transformation for your model. There are 3 types of geometric transformation: linear, p-delta, and rotational. In OpenSees, linear transformation does not account for any non-linear geometry, while p-delta and rotational do. Rotational accounts for it exactly, and p-delta is just an approximation of rotational. What geometric transformation does, it actually transforms beam element stiffness and resisting force from basic system to the global coordinate system. If I'm doing only Eigen Analysis, linear transformation would solve my problem. So here I'm just defining a geometric transformation to be linear, and it has tag of 1. Next, I have to define the elements. All my elements are elastic beam column elements. And if you go and look inside of the syntax for the elastic beam column elements for two-dimensional problem, you'll see that we need to define element tag, I and j, or I and j nodes, which are end nodes of the element, area, modulus of elasticity, moment of inertia, and transformation tag for this element. And this is what I'm doing for all the 6 elements that I have in my system. Now that I define my elements, my whole structure is defined. Next, what I can do is I can define recorders. The only thing I can record when doing Eigen Analysis is like our eigen vectors. I won't talk in details about how to define recorders. You just have to go to command manual and look at the syntax for this, as it differs from depending on what you're recording, what you're actually recording. In this example, for 2 modes that I'm going to calculate, I'm recording these 2 eigenvectors for all nodes and all degrees of freedom, and saving them inside of folder mode that will have names mode 1 and mode 2. I intentionally showed you this script as I find it very useful, not only for defining output files of your recorders, but also if you're like running multiple ground motions on your model, using this format command, you can create a nice model which will do all analysis at once in just one step. So next, I'm going to perform Eigen Analysis. To perform it, you need to use Eigen command. I'm going to go to the syntax for Eigen command. Here, for Eigen command, you can define the type of Eigen analysis. There are 2 options. You can do standard or generalized, where default is generalized. Standard problem solves the stability issues, and generalized problem solves the model problems. Next, you can specify this solver. There are many different solvers you can use. Default one is general band argpack. So if you don't specify anything for type and solver, it's going to use default values. And the last argument is a number of eigenvalues that you want to get as an output. Here, I'm assigning to variable lambda, I'm assigning eigenvalues of the first 2 modes as I assigned 2 to the number of modes. So I'm only looking at the eigenvalues for the first 2 modes. Since I didn't define the type and solver, I'm using the default ones. OpenSees doesn't have recorder for periods. So in order to see the periods of your structure, you actually have to know a little bit of programming, a little bit of TCL. So here I'm showing you how to create the vector which will contain frequency and period, 2 vectors with frequency and periods of your model. Next, I'm also showing here how you can write them into a file. So if you want to store your periods into a file, so you want to later look at the values, you can do that, or you can just print them to the screen. With this, I'm showing you how to save them into a file. And at the end, there is also in this example, there is a display command. Although OpenSees doesn't have any GUI, it has this recorder display, which creates some visual windows for you on your screen that you can see. In this case, I'm printing first 2 mode shapes of this structure. But this can be useful also for looking at the how your structure deforms or moves during an earthquake, and it's a real time. So as your analysis goes, your structure moves, and I find it very useful. And that's why I'm showing you. I won't go into details of describing this command, but if you're interested in using this, you can find a description of the command here. So after we defined our model and performed Eigen analysis and defined the display of the first 2 mode shapes, I wanna go with you through like downloading this file and running it on OpenSees. So by clicking here, you're going to see the summary of all I talked about. This is like the model. If you want to download it, you have to click at the link above which says download and save it to your computer. I'm going to save it in the folder where my OpenSees executable is. Now if I go there, I'll see my executable and my file. Now to run my file, I have to double click on executable, and you'll see the shell will pop out. To run this file, you have to issue command source that I talked about earlier, and it has to be followed by the name of the file that you want to source. So I'm just going to copy this file here onto the screen, hit enter, and I'm going to see on the screen periods, first two periods that are 0.62 and 0.23. I'm going to see mode shapes, mode shape 1 and mode shape 2. And at the bottom of the file, I also asked OpenSees to print on the screen first two eigenvectors. So with this, I will conclude this talk, and I'll answer any of the questions you may have. So please, you can either post your questions or ask me to unmute you and to ask me directly your question. So, do you have any questions?
Hi, Vesna. Can you hear me?
Yes, sure.
Is it possible to like open or save files as tickle files on a Mac?
Yes, it is.
Okay. Do you know like what application you or I guess I'm trying to save this text file that I have as a tickle, but the option for that isn't there. Have you ever tried doing that?
So your file can have basically any extension at the end you want. I think if you just download the same file I showed you here to your computer, and you have OpenSees executable on your computer and tickle installed on your computer so it can recognize OpenSees, you'll be able to run this application. Did you download OpenSees executable for Mac? The one I showed in the presentation is for Windows users only, but if you go at the bottom of the page, let me show you.
Okay, yeah, I believe I did download the .dmg or whatever it was for Mac.
So at the bottom of the page, it says the Mac version. So an OpenSees executable from Apple machines can be found and downloaded here. So if you click on this link, you'll get OpenSees version for Mac. Did you download that one?
Yeah, I did. But should I download the TCL/TK link you have up there? Okay, and that'll, even though that's an executable, it'll be able to like run on my Mac.
Yeah, it will for sure. So you just have to install it on your computer. You have to install some DLL files on your computer. So this OpenSees executable works.
Yeah, yes, that OpenSees thing works. So I'll just download Tickle too.
Excuse me, I didn't get it. Did you install Tickle TK on your computer or not?
No, I didn't install Tickle TK. I installed like Active Tickle. Like I searched for it for Mac because I thought that since that Tickle TK was a .exe file that I wouldn't be able to open it on a Mac.
Oh no, it is the same one. So you just have to install this one on your computer and it will work.
Okay, great, thanks.
Sure, welcome. So I got like few questions online in the chat. So I'm just going to answer them one by one. Xin, I have a question. Is there any pre or post processing software for OpenSees to help build a large size finite element mesh? In OpenSees, there are some other applications like OpenSees Navigator, which has pre and post processing software. And try downloading it and playing with it a little bit and see if it's going to help you. Disadvantage of that software is that it doesn't have all possible classes that OpenSees has, and you can have only run at a time. So you cannot, like with OpenSees, you can run multiple runs at a time, but with OpenSees Navigator you can do one run at a time. There is another question from Ashkan. Can we get a copy of the PowerPoint presentation? Yes, I'm going to post this presentation along with the video of the presentation as I'm recording it. I'm going to post it online very soon. Next question is from Hanjin. I have a question about fixity. In Pickle file you showed 1 is for fixed and 0 is for free. So can I enter a number between 0 and 1 from a partial fixed condition? No, there is no such an option. If you have partially fixed, you can use zero length element and assign some stiffness that you want to that zero length element. Zero length element is basically a spring, and that's the way to define partial restraints. But it can be either 0 and 1. It cannot have like intermediate values. Then next question I have from Andrew. I noticed the end conditions of the elements are not explicitly defined in the file. Is that part of the different elements comments? Yeah, end conditions by default are rigid. So if you want to make a pin, then you have to use equal-def command. But all ends are rigid, so are rigidly connected to each other. So for pin connections, you need to create 2 nodes at the same place and connect them with equal-def command, saying that the node that is pinned has the same displacement in x and y as the other one that is rigid, and this way you're creating pins. But if all your ends are rigidly connected to the other ones, then you don't have to specify anything. I'm going to go to another question now from Emmanuel. Can I get the PowerPoint presentation to keep the HTTP addresses? Yes, as I mentioned before, I'm going to post it, so everybody is going to be able to see it. I'm going to post it on the OpenSees website, and I will send an email to all of you that were here with me today, update about it. As soon as you do it, you'll get an email from me. Next question from Ignacio. Is it possible to model and analyze SSB with steel fiber inclusions besides rebars? I'm sorry, but I don't know what your SSB stands for. So I'll try to unmute you. So if you want to explain it to me. Hi, Ignacio. Can you try to explain me your question a little bit better?
Yes. My question was that if it was possible to model a simply supported beam with a point load or a distributed load that has, besides the steel reinforcement, which is the rebar and the zero, it has fiber incursions in it. The fiber keeps the concrete from forming cracks. Is it possible to do it with OpenSees?
I'm sorry, but the connection is pretty bad, and I couldn't hear most of what you were saying. Can you please repeat it once more?
Okay.
But try to speak slower. Try to speak slower, as you know, the connection is pretty bad.
Okay. I'm trying to model a beam simply supported with a point load that, besides having steel reinforcement, which is the rebar and the stirrups, it has fiber inclusion, and the fibers keep the concrete from cracking. Is it possible to do that with OpenSees?
Okay, I understood your question now. I'm thinking, and I don't know of any material that defines fibers explicitly. But what can you do if you know like how that concrete with fibers? If you know the properties of the concrete with fibers, you can define them with one of the uniaxial materials that we have in our in OpenSees. So there is no element where you can define the stirrups and rebars and fibers one by one. What you basically do, you define steel rebars, and then you define the concrete with the properties that it has once it has its stirrups and fibers inside. But you need to know these properties of concrete or fiber concrete with stirrups. You take into account this confinement effect. So if you know this, then you just assign this stress-strain relationship to your concrete and define like you use fiber section basically, and divide your concrete reinforced concrete section with fibers to define it with maybe up to 100 fibers, and to each concrete fiber you assign this uniaxial stress-strain relationship for the concrete that you have. Did I answer your question?
Yes, thank you very much.
Sure, you're welcome. Next question I have is from Xin. Does the current version of OpenSees also support the 64-bit window? At the moment, it supports only Pickle, that is 32-bit. So you can use 46-bit machine, but the Pickle that you can build on your machine has to be 32-bit Pickle. And Frank is working on updating it to 46-bit, but I still don't know when it's going to be done. Another question is it possible to model liquefaction problem using OpenSees? There is a work from a geotech group related to OpenSees that's done some work on this, and unfortunately I don't have I never used it, and I don't know much about it. But let's see if Frank is also in this call. If he knows something about it, he can help us. He can help me answer this question. Frank, are you there? I'm sorry, it looks like Frank is not there with us. So I'm sorry, but I don't have answer to this question. Another question, based on your experience, how much time do I need to learn OpenSees? So after this webinar, the whole intent of this webinar was to show you how, it's not that hard, it's simple. If you know how to efficiently use all the resources that we have online, and if you have like strong background in analysis of structures, it wouldn't take you long to learn it, because the structure or architecture of OpenSees is similar to any other software. So if you use SAP, you'll be able to learn it quickly, or any other like finite element modeling software. So I had a girl from industry that after a week came to ask me some questions about OpenSees, solving some problems, and after a week of starting or trying to learn OpenSees, she has such like a nice model, a very complicated one with nonlinear elements, friction elements, and so many very, very sophisticated things we have in OpenSees. So it all depends on your knowledge of finite elements and analysis of structures. So it might not take long. So, but the first basic step is just to learn some basics of SQL, and then like OpenSees is easy. That's my impression. Next question I have from Omid, who asks, how can I have access to C++ sources of OpenSees to create my own executable OpenSees file? I mean, how to add something to OpenSees. I'm now going to show you how to find the documentation for that one. So if you go to the, so now we are in the user page with all the information for users. But other than that, you see the link for developer. So if you click on that link, you're going to find all information about, you know, like what you need to know in order to add something. So here you have documentation, you have the ways of browsing the source code. You can download the source code that is now in there, and so on. So if you browse a little bit this page, you'll be able to find all you need. And basically, we have some examples here. If you click on the documentation, you'll find examples on how to add new material or new element. I think new element is only there. You have an example that will guide you on how to add a whole element to OpenSees. And adding material is all the same with a few minor changes. So if you follow this example, you'll be able to develop your own element. And please, if you develop anything, please share it with us, as OpenSees is community software, and that's how it grows. Next. Where do you post the presentation file? I'll send you an email and let you know. It's going to be here on the OpenSees page. There's going to be a new link with the Discovering OpenSees, with the name of like Discovering OpenSees, which is the name of this webinar. So inside of that, you're going to find it. Another question I have is, how can I find some examples about reliability problems? If you go to user documentation and examples, there's this sensitivity analysis that I didn't check for a long time. So if we have something, it may be inside of there. Or I'm not really sure, as I'm not working on this portion of OpenSees. I don't know if there is any examples. I know that there was talk about adding some examples, reliability examples, to this wiki, but I don't know if it ever was done. I'm sorry. Next question from Kolajvari. I cannot install Tickle on Windows 7. Do you have experience with that? I'm now trying to have you on, and you can tell me what's your problem.
Hello?
Hello?
You hear me?
Yes, I can hear you. So can you tell me what's your problem?
Let me just run it again.
So the first question I want to ask you, did you ever install it before, or is this the first time you're installing it on your computer?
I bought a new computer, and this is the first time on this computer.
Oh, okay. And did you, okay, sorry, say.
Okay. I was on the page when I was changing this C program and all that stuff. And I click next, and it asks me for demos, and I click next again, and it's like kind of a blank page. And after that one, it's an error of copying some files to C users. And then when I open details, it says, let me just, basically some permission is denied. So
Okay. Can you send me an email with the error message that you're getting? And actually, after this, I'm just going to try installing it on my Windows 7
Okay.
and see if I encounter the same problem. And then if we have some problem, we'll try to find ways to fix it.
Okay, sure. I'll just copy paste everything here and send you an email.
Sure. Thank you.
All right. Thank you.
Another question from Amir. How can we define rigid diaphragm in a model? There is if you go to user documentation, the command manual, you have to use multi-point constraint command, which is called rigid diaphragm. So if you click on that one, you'll see the syntax. And also, I want to show you the example where you can use to see how it was done. How you can, use it in an example. So if you go to advanced example manual, at the bottom, you'll have examples of 3D structures. If you go and look inside of these examples, there with rigid diaphragms, you'll find you'll find the guidance on how to solve your problem. Then next question from Mariam. Where should we enter the comments in the OpenSees exe? So yeah, you can do it two ways. One is if you go inside of OpenSees exe, so if you start executable OpenSees, you can type comments there directly. This is similar to MATLAB, so you can type comments directly and one by one define your model, line by line. But another and better way of doing it is just to create the file, so you can just like there are different editors that you can see that shows you the comments in different colors. If you're on Windows machine, there is like Notepad++, and there is like a Chrisman editor. If you are in Mac, if you're a Mac user, then like there is Pickle editor. So you just open that editor and start typing your file, your model, defining your model inside. After you finish, you give a name to that file, and then from the executable from OpenSees, from this black dot prompt, you just type source, like I did for my example. You just type source followed by the name of your file, and you click enter or return, and then your file is going to be your model is going to you're going to run your model that way. Probably now you have a question like where how to see your output. I didn't show you that. In my example, you remember I had recorders, so I'm just going to go back to that example I showed you. So here I define recorders where I saved eigenvectors, first two eigenvectors into modes folder, and names of my output files were mode 1 and mode 2. And also I saved my periods into a file in the same folder. So if I go and look inside of my folder where my file that I executed is, you'll see the folder modes. If you go inside, you'll see all files that I've saved. This is basically your output. In order to populate the output, you have to exit OpenSees. After I close it, you'll see that from 0 it changed to 1. So now there is something inside. If you open it, you'll see the first eigenvector inside, and then the second eigenvector inside. And then in periods file that I created, you'll see the first two periods of the structure. Next question is, There is a question if from Chinshu, do you have examples for masonry structures? There is only one example that you have on masonry structures. So if you go to examples at the bottom, you'll see these practical examples, and then there is one which is called infill wall model and element removal. And actually, I'm not sure if this is really what you need, but this is not actually masonry structure. This is the example where the infill wall was modeled. And this is all we have. There's some. This structure is not masonry, but there are some masonry elements inside of the structure. So this is the only examples we have of masonry structures. So another question is, from Marion, I need to know why sometimes when I run a tickle script, I don't have any answer in the files resources. I'll try to have you on so you can explain me better what you meant by this. Marion, would you please try to explain your problem again? It looks like he is not there. Then I'll go to the next question from Quincy. Is there a function in OpenSees to apply a consistent load vector for a distributed load on a member? I don't understand this question again. So Quincy, if you're here, she is not there anymore. There is a question from Miriam. In SAP, we don't enter the data by commands like OpenSees. Yes, that's true, but the whole structure, the architecture, and the philosophy is the same. The difference is that OpenSees doesn't have any pre- and post-processing, and SAP has it. And then again from Marion, I was running the example of the manual fatigue material example tickle, and I didn't find any answer in the recorders file, damage out, or even in the stress strain out. If it was completely empty, you probably need to exit. You have to close OpenSees to populate your answers or your output files. That's one thing. Or you can issue wipe command at the end of your file, and your output files will be populated. So like 2 ways: close your OpenSees executable or have wipe command at the end of your file. From Olympia, hi, does OpenSees calculate the ultimate curvature in a section analysis? No, it does not. Depending on how you create and define your material, it can you can make it fail at some point, but if you don't define anything, OpenSees won't do anything for you. Another question from Unicarita. Is there a build available for Linux, or do we need to build it from source? I'm sorry, but I don't have an answer to this. Frank would be the right person to give you the answer, but let's see if he is there. It looks like Frank is not with us now, so I'm sorry. Would you pose a question on the message board, and I'll try to get an answer from Frank about it. From Amir, is there any way to model steel or RC shear walls in OpenSees? There are ways, and it's not so. I'm just going quickly to show you one element that may be useful if your element is 2D. If you go to user documentation and to command manual, there is element which is called flexure shear interaction displacement based beam column element, which is for reinforced concrete shear wall, but is only 2-dimensional. I don't know if this is of use for you, but for steel, there is no element as this one is. But using what already exists in OpenSees, you can create your own material, and I know people that were doing that. From Anton, does OpenSees have been tested before? We have many users that are using OpenSees, and it's proven to be stable, reliable, and extremely fast. Another question from Miriam, is it possible to create a model in OpenSees without typing comments? I mean, in such a way we do for SAP, that we can see the model instantly. There is OpenSees Navigator that does that for you, and it has preprocessor and processor. But OpenSees, the one that I showed you right now, cannot do that. But there is OpenSees Navigator. So try to Google OpenSees Navigator and you'll find it. From Marion Castro, when I run a script, sometime I don't have answers in the recorders. Why? I think I already answered this question. Is it possible to model the local buckling of beam steel members in OpenSees? I mean the stiffness degradation that occur after the buckling. Yes, it is possible to do it. There is a whole peer report on that issue. If you want, post this question, because the answer is not short, post this question on the message board and I'll give you the references that you can use in order to do it. Then from Marion, maybe write the response you give me because you speak quickly and I don't understand, and send it by mail. Sure, you have my email. So if you could not understand what I was speaking, send me an email with your question, and I'll give my best at explaining it to you. Another question from Andy. Is there any resources to guide us to define the parameters of pinching for material? Thank you. There are no. We do not have any. There are no resources that explaining that. If you need more than what's there online, you have to. It's contributed material, so you have to contact the developer of that material to get more information about it. From Olympia, you said that it depends on the materials that I define. For reinforced concrete section, if you use Stilo 1 and Stilo 2, what else do I need to define in order OpenSees to calculate the ultimate curvature? You need to put a limit for strains in your materials, and the way to do it is to use min and max command, min max uniaxial material. So if you go to uniaxial material, there is this command min and max that puts the limits to your strain, and this way you're limiting also the curvature at the end. Next question. What is the unit from Anton? What is the unit of OpenSees, SI or British? OpenSees is unitless. You just have to be sure that the numbers you're putting into OpenSees are in the same units and consistent. Don't mix them, but there are no units. For Miriam, I'm wondering if you have some questions after this conference, how we can ask you. There is a message board. So on the left side of the OpenSees page, there is a link to a message board. And the first one is for problems you have with OpenSees executable. If you click on that one, I will get to the forum, where you can either, by typing at the top, you can search, type like some keywords that can show you what are the previous posts on like problems that you have. Try to find it there. If there is no an answer to your question, if you cannot find it on the message board, post your question there, and I'll answer it. Or please, if anyone else knows the answer to any question on the message board, you're very welcome to answer it as well. Okay, these are all questions I had so far. As I'm not getting any more questions, I think this is the end for this webinar. I hope after this presentation you have some, you got some instructions on how to start learning OpenSees, and I hope it will help you in learning it quickly. Thank you for being with us, and have a nice day.